All right, folks, thanks for joining in here. So I got a couple PowerPoints here just to kick off with. So we're going to start with generative design. So what technically is generative design? So it's an algorithm that you can utilize on your parts to reduce amount of weight and to now utilize strength, stress, torque loads, multiple types of loads on it to help you design a tool that will fit your needs. So typically in the past, it was kind of an organic shape because it was really initially created for 3D printing. So it's more of an additive process. So they gave you some kind of funky shapes to start with. But now in 2019, they did away with that type of process. And now we have also, in addition to it, a machine type feature creation inside of generative design. So it's more like a part that you would actually put on a CNC machine and do a subtractive process than you would on a 3D printer adding it. All right, so what's new in 2019 is the ability to add multiple forces to faces in the simulation. Before, we had a single face that we could do a load on, but that has gone away. All right, so let me get into the first one we're going to take a look at is not this one, but that is the one we're going to look at last. Let me kick over to Solid Edge. All right, so to give you a simple run through of how to set up a generative design, I'm going to use this part. This is just a sample part Siemens provides. Pretty simple process. I already have a generative design set up. So if I go to my generative design tab, we have all the different loads that you can actually turn on and see the loads. It actually tells you the amounts, where the constraints are, etc. So how do we set this up? So I'm going to do another design study. So under Generative Design tab, I'm going to create another study. So I'm just saying create new study, and of course it creates another study right below it for me. All right, so now we just go through and tell it what we want to do. If there's any regions we want to preserve, for example, if I wanted to say, you know what, I don't want these bosses to change shape or that face to change shape. So we can go ahead and constrain those to be the shapes that they are. Everything else in gray can change. All right. So then, again, we have the force, pressure, torque loads, gravity loads, etc. So I'm just going to do a force load on that face right there. And of course, we got our arrow dimension. I want to go the other way. So let's flip that around. And again, I'm just going to use the same amount. If I wanted to use a different amount, so I can run multiple iterations of a generative design to kind of get to the most refined part that I want. So you can do the same study, just applying different loads and different force amounts. And as I mentioned, we can apply another load on here if you want to do a force on this face as well. So we can apply as many forces as you want, I think, and it will just let you, oops, I don't want to put that one on there. So now I'm going to go to my next step is fixing some geometry, because it has to have some kind of point of fixed location. Otherwise, the analysis won't work. So we have a couple different ones here. Pinned, this is a fixed with a rotational value. So maybe this actually spun around a shaft. Then you can apply that pin load. If these are fixed, so let's say it doesn't rotate, these are bolted to something and something pushes it, you would use a fix. So I'm just going to throw a couple fixed loads on here. All right. Then we go to manufacturing settings. All right, so we have some options here. And as I mentioned in the PowerPoint, I said we have some effects that allow you to make a machine type process. All right, that would be down this end of the spectrum, no effect. It'll subtract the amount of weight that you want and give you your final design, but it won't give you all the little tendril style like we did in the previous version. So in SD10, the typical style was the thin wall tendril style. So it gave these long kind of weird little protrusions. Again, specifically for 3D printers, not a problem. For machining, impossible. All right, so that's why they added this down here for continuous solid structures that would be machined. All right, then we have some options here to tell it how to create these features. We can tell it to prevent axis overhang. So the y-axis is the thickness. So if I didn't want this part to grow in the thickness, but change planarly, that's where we want to go with. Then I can tell it which way we want to extrude it. We have the options to extrude positive, negative. Then once you're happy with that, you say okay. Did I not give it? May have not accepted the force. Oh, okay. I didn't accept the force while ago. Actually, let me flip that. All right. Then once you're all happy, done, you run generate. All right. So here's where we're investing the time that we want to run on this. All right. So the first thing you typically want to do is tell it how much weight, and by default, it'll pop over to 50%. So it's going to reduce this by half. If if you can try to get greedy and come over here and say, well, I want to reduce it by 85%, and it'll run through an iteration or two before it'll come back and say, hey, you've exceeded the amount of material you can remove and still maintain that force on that face and have a structural rigidity. All right, so you can also type it in. So right now we're at 31 kilograms. So if you want to get to a specific value, you can just type it in right here. You don't actually have to use that little slider bar. You come over here and say 20, and there you go. Then you just hit generate. All right, we're set on low, and this will still take a few minutes to generate. It says 1 minute, 24 seconds, and on my laptop, it is not 1 minute, 24 seconds. Somewhere around here in this value, like a 30-minute range, is going to typically, depending on the geometry that you're working with and the complexity of the forces, could take an hour or two. I've never really messed with the range over here where it says 3-4 hour kind of range. My laptop, I don't think, can handle that type of thing. So, you typically want to start low to kind of get close to where you want. Then you can refine your study by bumping it up and letting it run in the background. All right, so don't need to do that because that will just tie up this demo. So let me just kind of show you what we have here. Let me turn off the design body. So, oops, not that one. Let me turn off some of these things on here to show you what we kind of ended up with. So as I mentioned, this is more of a machine type process. So you can obviously easily mill that out to a shape.